Hello, in this screencast we are going to walk through one of the items from the first exam here in Statistics 1 for 2019. Specifically in Task 5, the first item that we were assigned. And I want to walk through the process from scratch on this problem here to hopefully clear up some misunderstandings and also to help lay a strong foundation for this topic from here on out through the course. This is a critical type of item that we need to be able to understand and use throughout the course. So I find it important that we make sure we get it straight here now before we move on to the next chapters in the text. So for this item, the prompt says, for test number 2, determine the proportion of the population that you would expect to score above a 90. So in the original directions, it talked about treating the students' test scores from earlier in the test, from the data set, as if they were larger and normally distributed for the entire population. And so for this item, there's a few aspects we need to focus on. And from here on out, we need to make sure that we are very careful with the specific notation and items that we were focusing on. So here we were taking a look at test item 2, or test 2 from the data set, and also we're looking at finding the proportion of the population expected to score above a 90. So from earlier in the test itself, or exam 1, we needed to take the data that we found and the statistics we found about test number 2. So test 2 ended up having a sample mean of 81.32 and a sample standard deviation of 9.28. And what that looks like then is on a normally distributed curve like this, or set of data, that mean of 81.32 here is dead center at the middle, and each one of our tick marks going out is going to have a value of 9.28. So this standard deviation, again, is the value of each of these tick marks working out. And they then translate to our z-score, which is then used to identify the area under the curve from Table A. So first step we have to do now is find our z-score. And the formula for the z-score, as you recall, is that we take our actual data point, in this case it's going to be a 90, and we subtract from it the sample mean, and then we get that difference. We're finding out how far our value of a 90 is away from the mean. And then once we take that difference, then we divide it by the sample standard deviation. So for this specific example, we subtract 90 minus the 81.32, and we get a value. It's pretty close to 9. And then we divide that by the 9.28. And that gives us a z-score of positive 0.94. And what that does is it tells us that our value of a 90 lies right about here, just shy of one solid tick mark. All right. If it was a z-score of exactly 1, then we would be 1 standard deviation above. If it was a z-score of 2, then we would be exactly 2 standard deviations above. But in this case, it's 0.94. So then what we need to do is translate this problem that dealt with, the real life mean of an 81, standard deviation of 9, and a value of 90, to translate it onto this normal curve. And we need to find the area under the curve from this value, right about here, towards the right tail. And the reason why we know that it's towards the right tail is because of right here, where we're looking for finding the proportion above a 90. If it was below a 90, then we would find the value from here all the way to the left tail. But in this case here, it is above a 90. Now what do? We take the z-score and we go to the table in the back of the text, Table A on page 458. And we go down the columns until we find the z-score of 0.94. And once you find that point, you go across that row, and you'll see that there are two values given. One is the 0.3289 and one is the 0.1711. Both of these are associated with the z-score of 0.94. But the key is to understand what they both stand for. And at the very top of each column, you'll see a chart, or a sketch, one that looks like this for column B, and one that looks like this for column C. This is a legend here telling you that this value is the area under the curve from the z-score that you found here of 0.94 towards the mean, or towards the middle of the graph. So the area in that interval from a z-score of 0.94 to the mean is 0.3289. The right column, the far column on the right where 0.1711 is, that is the area under the curve from that same z-score of 0.94, but towards the tail. And which one of these you pick depends on the problem itself. So in this case here, we were looking for the area under the curve above a 90, which meant from this value right here all the way up to the right tail. So I'm going to use this value here of 0.1711. Realize again, this means this is the proportion of the population that we expect out of that same group to score above a 90. That would translate to 17.11% if you left it in percentages, but we were looking for a proportion. In that case, we leave it in the decimal form of 0.1711. Hopefully that helped walk you through that item from the test. Other items in the test were very similar, but you have to read carefully whether or not you're dealing with the statistics from test 2 versus test 3 or test 1. Each of those had different values here. Also, what was the challenge was understanding whether or not you're looking for the area under the curve from a certain value towards one tail or the other tail. And that depended on which one of these graphs you used, or which one of these columns in the table you used to help define the area under the curve. Hopefully that was helpful in clearing up how to solve that type of problem.